Okay. Chapter 3. Coolbox. Now, again, we're going to go over a lot of the things that you should have seen already at one point in time or another. Exponents. You guys are aware of exponents. I mean, that's not that big of a deal. You know, a squared just means that we have a times a, not 2 times a. Now, the properties of exponents, these things, if you do not have these memorized, and trust me, you need to become one. You shouldn't have a problem with that, and if necessary, write them down so that you've got access back and forth. But these things right now you should have memorized. Of course, division by 0 is always equal to 1, and division by 0 is undefined. Anything to the 0 power is 1. Two things that you got to keep in mind. Now, the nice thing about this idea with the 0, keep in mind it in these terms. It's not perfectly accurate, but it does work. Anything to the 0 power is 1. So if I take a look at A there where I've got 4C in parentheses to the 0 power, that's 1. If I take a look at the one next to it, that's 4. Because only the C has the 0. Parentheses aren't around it. Okay? So please be aware of that. Absolute value. Now, absolute value, everybody thinks, oh, it always just makes it go positive. Think of absolute value in the terms of a number line and how far away something is from 0. Because distance is always positive, this value is always going to be positive. However, a lot of times people forget if there's a negative out in front of it, they don't carry that through. Follow the order of operations to make life a lot easier. Now, the next piece down here, handy little piece of information. Rational exponents. Fractional exponents sometimes are a lot easier to work with and have a lot more tricks for us to deal with than just a root. So these I know that you haven't played with enough. Make sure that you have that piece of information down. We're going to take a look at how we deal with some of this stuff. Let's see. So, if I am going to write this in the form of an exponent, or a fractional exponent more precisely, this is x squared over 3. That's all it is. For b, that would be x, what's the power? 3, what's the root? 4. 3/4. Over here, I don't have any number in here, so what number would be there? What kind of a root is that? If you just got that plain symbol, what do you guys usually call that symbol? Square root. So that means that there is going to be a 2 sitting up. Now for this one, this is going to be all of those to the 5th power. Well, what's 3 to the 5th? Well, that's 3 times 3, which is 9, times 3, which is 27, times 3, which is 81, times 3 again, which is 243. So this would turn out to be 243, okay, x to the 5th, y to the 5th, okay, all to the 1/2 power. Now, Is it possible to take the square root of 243? And actually the answer is
Mr. Bosacker, is Gibson come to the office?
on his way.
Thank you.
Now, if we were to go through and do this all of a sudden looks really ugly, doesn't it? A little bit of nastiness going on. Okay? There are a lot of different ways of dealing with this, and it all depends upon what you see, what comes to your mind to begin with. So the most straightforward way I've got is this. Can I take the square root of 243? And the answer is actually not really. I can't come up with a nice whole number. So, should I leave it that way? But the instructions were to write it as what? What did the instructions say that I was supposed to do? With exponents rather than radicals. So do I want to go through and actually simplify that out? The answer is no. Be careful. When they say write it as a fractional exponent, follow the instructions. 5/2, that's all it's supposed to be. Because that's all the instructions say. Okay? This one, 3 is on the outside, right? I got x and I got y in a set of parentheses, and what's their fractional exponent going to be? 5/2. Now again, I've been noticing that some of you just kind of dig into the problems and don't bother reading. Please read. Now, if we take a look at the other ones they've got here, it's just going back and forth, writing it in the radical form. Reverse procedure. That'd be the square root of y, which is exactly what they got. 7/3. Okay. Root is 7. I should say 3/7, sorry. Power is 3. See how they write it. 12. 3/5. Power is 3. Root is 5, but mind you, it was only on the x. Please be very aware of that. Well, let's see. Yeah, you guys can multiply. You guys know all about FOIL. What was right there? Special binomial products. These are kind of handy so that we're able to go and quickly do something. If I know that something is going to be a difference of 2 squares, I know it's just the first term squared, second term squared, and it's subtraction. You don't have to go through the whole FOIL thing. Okay. If you take a look at this one here, a plus x squared. Square the first term, square the second term, multiply the first and second term together and double. 2ax. Likewise for the subtraction, exact same thing, except that now they're minus. The more you do of those, the better off you're going to be. Now, factoring. There are times that factoring is a necessity, and sometimes factoring can really hinder the situation. Factoring really comes out as the reverse of multiplication. You know how to do FOIL, you know how to do the distributive property. Now what we got to do is kind of figure out what's in common, what do they both have. So, if I am going to go and set this up so that there was something multiplied by something, by 2 things on the inside, okay, we look for what's in common. Well, is there anything that's in common between a 4 and an 18? If I think of the factors of 4 and if I think of the factors of 18, the only thing that comes to mind is a 2. They're both even numbers, right? So 2 times what is 4? That's easy enough. 2. 2 times what is 18? 9. Now, when it comes to something that has an exponent on it, if they are in both terms, take the smallest exponent. Do I have an x under both terms? Yep. What's the smallest one there? Just a plain old x, 1x. So that means if I pull an x out here, there's only one left here and there's none left over there. What about the y's? How many y's are in common? 3. There's 3 in the first, 4 in the second. So I can take a maximum of 3 out here, and of course there won't be anything left. And over here there would be just one y. Now, I said this was the opposite of the distributive. If I take this and multiply by that, 2 times 2 is 4, x times x is x squared, y, there wasn't any, y cubed, minus sign minus. Now if I do this over here, 2 times 9, 18, x, no other x, plain old x. Y cubed, y to the 4th, or 1y over here, so I end up with y to the 4th. It takes me right back to where I need to be. Okay. Sort of kind of makes sense? Like I said, the more of these you do, the better off it becomes. Now, B looks just plain ugly, doesn't it? Is there anything in common? And the answer most definitely is yes. It's AX, or A minus B and A minus B are in common in both. Why? If I take a look at this, you probably want to go and say, hey, why you would do distributed property, add like terms, and do everything else on it. Problem is, we need to learn to think of things that are multiplied together as single units, single entities, one thing. The 3 is by its lonesome. The x is by its lonesome. Anything in parentheses by its lonesome. It's one number. It's a value. It has something there. However you want to look at it. But don't look at it as, oh, A minus B. Is A minus B some number? Nope. Do I know what the number is? Nope. Do I care? Nope. All I want is to identify that it is a value. So in this case, I can go and pull out parentheses A minus B. Now what would be left? If I take A minus B away from 3x, I'm just left with 3x. If I go and take A minus B out of this, I'm just left with minus 2y. Okay? It is another factoring technique that we will be coming up with. Once we start getting up to more complicated expressions, we'll need to be able to pull these things out based on this idea. Little substitutions. But this is just the beginning of it. Let's see what else do we got here that would be of interest. Check. Okay, those are the rules there for that. So, let's grab one of these and solve. Factor. So I want to go through and factor these out. Are there any commonalities? Take a look at A. Is there a common value between 33 and 72? Is there? Anything I can divide out of all three? That's just supposed to be yelling out 3. How do I know 72 is divisible by 3? Add the 7 to the 2 and I get a 9. Is 9 divisible by 3? Yep. So 72 is divisible by 3. So if I go through this and factor out a 3 first, what is left? Well, that would leave me with x squared minus 11 plus, well, what's 72 divided by 3? 24. Now, how do you factor the rest of that? Well, this is where having a little bit of knowledge is going to help. One is both going to be negative. Okay? How do I know that? Well, if I go back here, whole sec, didn't put that one in there. Think about it, they don't have that one in there. Yeah. If I know, let's see, what, they got it down here. Trying to remember if they actually put that in here. No, they did not. Okay. Okay, I'm going to give you a little. They don't have it. So, I'm going to give you a little something to work with. Okay? If it is in the following form: x squared plus something x plus some number. How it is always going to factor out will be as follows. This will be an x, that will be an x, this will be a plus, this will be a plus. You'll have a couple of numbers in there and I don't know what they'll be. If the pattern looks like this, x squared plus something x minus some number here. It will factor out as follows. X here, this will be positive, this will be minus. Except that there's going to be a way that these numbers are going to be identified. This will be the larger factor. This is going to be the smaller factor. You take a look at these factors, the numbers, and I'll show you what I'm talking about in a little bit. This is how it works out. X squared, and what happens if there's a minus? We got some number, x, plus some number. Okay? Don't know what those numbers are. This will factor out as follows. This will be an x, that will be an x, this is going to be minus, that is going to be minus. We don't care about anything about those numbers. They'll just be there. Last one. X squared minus some number x plus, oops, same minus some number over here. This will factor as follows. So it would be x and it would be x. One is going to be plus, one is going to be minus. The thing is, this is going to be the larger factor and this is going to be the smaller factor. And I'll show you how those work in a moment. So I'll give you a little bit of time to get that written down. Okay. So now, I'm going to go back here. I said we had to take a look at the factors. What we're going to do is we're going to look at the factors of 24 here. So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't show up, and 6 has already been identified. Now, these signs are the same. So if the signs are the same, that means the numbers are going to be added together. that middle term. So what pair of numbers there adds up to 11? 3 and 8. Doesn't matter where I put either one of these. Now, I'm going to go and check just to make sure that I actually did that correct. X times x is going to be my x squared. This times this, minus 8x. That times that, minus 3x. That times that, plus 24. So when I look at these middle two terms here, will negative 8x plus negative 3x give me negative 11x? That's the process. So I take a look at A or B here. Do I have anything that can be factored out? And the answer would be no. So that means I'm going to have to set this up so I can factor it out. Well, if I remember what I had written down over here correctly, negative or minus minus plus the smaller one minus the smaller one. So that means I'm going to have x, just a wee bit more space, x plus 1 and x minus something. What are my somethings going to be? Well, what I'm going to do here is I'm going to multiply those together. 6 times 1 is what? 6. So I get 1 and 6, 2 and 3. Those are the only possible factors, right? Now, because the signs are different, I have to have a difference of how much? 1. So I need to arrange these in here so that the number that is larger is negative, the number that is smaller is going to be positive. So I need to have my 3 to be negative. So if I put my 3 here, and now I need to be able to get to 6. Well, am I going to be able to put my 3 here and multiply something to get to the squared here? 6 squared? And the answer is no. In order for me to do this, I am going to have the 3 here and a 2 there. Will that now get me 2x, or correction, 6x squared, when I multiply them together? Now, the only thing I got left is 1. What numbers multiply together to get 1? 1. Okay. Now, will this work out for me? Let's check the middle terms. If I multiply these two together, that gives me negative 2x. And if I multiply these two together, that gives me a positive 3x. Did that work? Does that get me to my negative x? The answer is no. So I'm going to have to back up and do something different. What do I really got to change? If this scenario did not work, if this gave me a positive 3x, what should I switch around so that I get a negative 3x? The 2's and the 3, right? If I go and switch this, and I put the 3 here and I put the 2 here, will this do it for me? If I take 3x times negative 1, that gives me minus 3x. If I take 1 times 2x, that gives me plus 2x. Do I get the middle term that I'm looking for? Now, the more of these that you do, the easier that will be. You will see where things are going to go. There are bits and pieces of the stuff that you can do in your head that in the time that it takes you to write down and you're looking at it, you can process that information, say, hey, that's got to be negative, so you put the negative in. This is an experience thing. The more of these you do, the better at them you will become. So they give us some information here as to how to go through and factor these things out. It's helpful, sometimes not so much, sometimes yes it is. So we're going to try this one out here. If I go through and look at example 10 here, they start off with this. They multiply these together and they do a whole bunch of wonderful stuff there to get us. Okay? Does that seem an easy way of doing things? Maybe. Maybe not. Let's see. If I was going to deal with this one, what would I do? Well, they want us to use grouping, and quite honestly, sometimes it's not the easiest way of doing things. So, go back here. Let's try this one. So, if I looked at this and was going to try and use that grouping method, and grouping method does work well in some instances, other instances not. Okay. So, here I go. What I would do, what's 5 times 10? 50. So what I would do now is I would go through and I would identify all the possible factors of 50 here. So that's 1 and 50. Let's see, 2 and 25. 3 doesn't go into it. 4 doesn't go into it. I get 5 and 10. Nothing else goes into it. Now, I do know that it's got to factor out as to the x and x. 1 is plus, 1 is going to be minus, correct? Are there any factors here that, when I add these together, find the difference of them, that the difference is 23? Well, what's the difference between 1 and 50? It's 49. It won't work. What's the difference between 5 and 10? 5 won't work. What's the difference between 2 and 25? 23. And what are we looking for? 23. So I know that I am going to have to use 2 and 25. Now, what are the factors of 2? 1 and 2. What are the factors of 25? Well, 1 and 25, or 5 and 5. Do I see a large number like 25 in here or here? The answer is no. So it is going to be some combination of this. So I need to get to a 10. How do I get to a 10? Using the factors that I've got right here. I need to get to a negative 5. What do I need to multiply through by a negative 5? No. What I know is that 10, that's got to be a 2 and a 5, correct? Now, the next place, I won't put a 5 here. The reason I won't put a 5 in here is because do these two get multiplied together? And if they get multiplied together, am I going to get a number bigger than what I've got? Yeah. So, 5 can't go there. That must be a 1. I need to have a 5 here, so that's going to be right there. So now, the next question is, will this work? If I take 2x times 5x, what do I get? 10x squared. That works. If I take 1 times negative 5, gets me that. Will I get the middle term if I use this setup? And the answer is no, because 2x times 5 and 1 times 5, that isn't going to get me to 23. Do I need to have something go to a 25? Do I need to go above? And the answer is yes. reason why is because it's a difference. I was kind of hoping somebody would have said, oh no, we're going to need that 25 in order to get to the 23 because we got to subtract. I kind of hope you guys are going to say that before. But, oh well. Move these, move these. So I'm going to put my 5 here, I'm going to put my 1 over here. Will this get me to what I want? Now, we've got it set. It's going to take care of the end terms. It's the middle term that's what we're worried about. This gets me 25x. This gets me negative 2x. Will those two things put together get me the middle term? And the answer is yes. A lot of times you have to play with this stuff. Okay? Put the numbers in where you think they might go, and if it didn't work, switch the numbers around. Come up with a different order. Now, last thing that I need to talk about here, complex numbers. Now, complex numbers really aren't all that complex. Does anybody know what the square root of 4 is? Nobody knows what the square root of 4 is? Yes, sir. 2. What's the square root of negative 4? And of course, somebody comes up with negative 2. 2i. Yeah, it's got to be 2i. The reason is, when we're taking square roots, we have to have two things that are exactly the same multiplied together. So, what they did is they came up with this wonderful little idea right down in here. I is equal to the square root of negative 1. Okay. By going and creating that, they were able to build a system that allowed you to deal with the square root of negative numbers. Now, a complex number is always going to be in the form of a plus bi, where a is a whole number and bi is the imaginary part. Complex numbers are actually the next step up for the sets of numbers that you're accustomed to dealing with. I know you guys know all about the real numbers. This is the next step above those that adds in the imaginaries. Yeah, and they kind of come in really handy, like that little picture that they've got there. Fractals, imaginary numbers come in there quite a bit. Electrical circuits is really where they came up with a lot of this stuff. That all of a sudden they had to figure out a way of dealing with that. So, here we go. We're going to simplify these down. So, if I want to simplify the first one, that's as simple as it gets. The 6, this 8, I got to deal with. Well, because the 8 has a factor that's a perfect square. The square root of 8 is I'm going to break it up like this. 4 times 2 times negative 1. Okay? Now, the 4 would come out as a plain old 2, correct? The 2 I can't do anything with, so that's just square root of 2. What about that negative 1? Well, if I get a negative 1 in there, that's just going to come out as I. Now, depending upon the book that you're looking at, author, sometimes you'll see it written like this. Okay? Either way, the order of multiplication doesn't matter. I don't necessarily like putting the i's out at the end because it ends up messing with things. Okay? What about b? Well, that would be 4 over 2, which is a plain old 2, correct? I got a negative. Square root of 6. Is there anything in the square root of 6 that can be taken out as a perfect square? And the answer is no. So this would simply be the square root of 6 over 2i. That's all it's going to be. So it'd be 2 minus square root of 6i over 2. Now you'll see me put the I out there. Sometimes you'll see me put the I out in front. It doesn't really matter. As long as the I is in there, it's there. but that I takes care of that negative square root. So I'm going to leave you there, and I'm going to let you start working on these things, and tomorrow we will go over and answer the questions and dig in